Hello guys, Daniel Dallas right here, and today we're gonna start a new topic for quadratic equations. So we start from basics because before we start linear equations also from the basics, we consider like several approaches and then just basically trying to extend that into fractional one and to more complicated. So here will be the same approach. So that's why I just remind you, quadratic equations simply as an expression in the form ax squared plus bx plus c. This is really the full or complete quadratic equations, and to the right side it should be definitely zeros. So I highlight a, b, and c, which are simply coefficients, and the key role here is to the leading term. So the leading term, ax squared, has the power x equals 2. So that's the maximum power. And if you probably know what polynomial structure is, so that's simply p2 from x. That was called quadratic expression. That's p2. So probably just bear this term in mind. You'll need this in IB or in A-level study. So, and this referred to this quadratic structure. All right, so what quadratic equations and what's the difference from the linear one? So we see the structure where the terms, the leading terms with the maximum power of 2, then we have a term of x, and then we have a free coefficients. Okay, so if you write standard linear equations, I can write in the form bx plus c, so no matter which coefficient you will use. However, the variable here, x, tells you that the maximum power of this expression is 1. So because imaginary, this power is just 1. And looks like this part is the linear part, right? This is the linear part of the expression or equation, because it contains x in the power of 1, as we've seen in the linear expressions and equations. So simply, this is the linear, and what makes your quadratic equations to be quadratic? Of course, the leading term. So basically, this sort of extra that you add to linear part. Okay, so just by looking forward, what if you want to create the cubic structure? Okay, that's simply p3 from x, cubic. I just give you an analogy to provide, understanding how it works for like general n power. So p3 is simply ax cubed plus bx squared plus cx and plus d. In this case, I'll use a bit more quantity of coefficients, a, b, c, and d. And of course, you understand that if you compare, this is the linear part, linear. This is what is called quadratic, and you can extend in combination with linear, so quadratic. And if you combine with x cubed, that's cubic term, right? That term is leading and it's cubic term. You'll get cubic equations. Of course, you can arrange power more than 3, but because we are on the basics and we are not going to do it here. So, right. Hence, we have the following: x squared plus bx plus c. This is standard like expanded form or complete form with all terms here. But what if, let's say, b equals 0 and c, let's say, equals 0? What will have in this case? So case number 1. In this case, we'll just get x squared equals 0. And what we're going to say, if a is not equal to 0, so obviously you'll have only one solution, x equals 0. So because we'll have x squared equals 0, so that means x by x is 0. And you probably know or remember How it might happen? Obviously when each x is 0, so simply that's one solution. So we have just only one solution. All right, case number 2. What if we have c not equal 0? We'll get the following: ax squared, so and b is 0, so plus c equals 0. Okay, so how to cope with that? So simply, you just need to transfer as with normal linear equation. Just remember linear equation basis. If not, just try to go back, because this is very significant, and before starting quadratic, you need to be very well with linear equations. All right, how to work out x value? We can transfer c to the right side, so we'll get negative c. And from here, we know that x squared is simply negative c over a. What we can do next, obviously, the whole part, negative c over a, should be positive. So we can say that negative c over a is more or equal to 0. Okay, and from here, how to solve that? So typically, it's better to represent this negative c over a as k, like sort of new variable. Not new variable, sorry, just new number that equals to this fraction negative c over a. So in this case, you'll have x squared equals k, and that what is known standard equation, standard quadratic equation without like other form. That what is called equation of the form x squared equals k. How to resolve it? So this is the simplest form of quadratic equation. So simply you might have x squared equals 7. How to solve that? You just simply need to take the square root of 7. Why? Because you can apply square root to both sides. And when you take the square root of the x squared, let's consider how it works. It simply works if you remember indices or index topic. Let's remember index, how it works. So x squared and square root of 2 is simply the power of 1 over 2. You'll get the following, so x, and you need to multiply the powers. And if you multiply the powers, you'll get simply x to the power 1. But the problem is in the following. So you might have as x just as positive x as well as negative. Why? Because if you have like negative x, squared is also going to be the same. So x squared will be positive. So actually, when you apply the square root to square root of x, you'll get two possible answers, plus x and negative x. And that's why x itself will be equal to positive and negative square root of 7, as in this example. So generally, it looks like you'll have square root of k and plus or minus. So because you need to have, you might have two possible options. Okay, so first of all, let's prove in this example why square root of 7 fits out as well as negative square root of 7. So we can just try to check it. So we're considering x squared equals 7, and now we just want to check whether this solution is a real solution for our equation. So what we can do, we just simply take the square root of 7 positive and square it up. All right, so first we have check x1 equals square root of 7. So we just simply take square root of 7 and raise to the power of 2. And finally, we need to get 7. So is it 7? Of course, yes, because we just apply 1 over 2 and just square, right? which is 7. So, and 7 equals 7, that's correct. Now let's try to check another root, which is x2 is negative square root of 7. Okay, so we put negative square root of 7 and square it up. So by definition, what does mean a square number? We take under square expression, negative square root of 7, and multiply by itself. So we take that and multiply by itself because of squaring up. And what we'll see that two negative numbers during multiplication will give you positive number. So that's why it's going to be positive, and square root of 7 times square root of 7 is square root of 49, which is simply 7. Okay, so that's why both answers correct. So to recap, how to solve equations in the form x squared equals k. Let's say, let's list several steps. So you have the form, the simplest form of quadratic equation. X squared equals k. All right, so first of all, as you understand, because x squared is a positive value finally, even if x itself is negative, so squared is always positive, or zero value, so we need to mark that k should be always more or equal than 0. So if k more or equal than 0, so we might have 2 or 1 solution. So one solution in case k equals 0, right? One solution. And indeed, if x squared is simply 0, we'll have x equals 0, and this is the only solution, and it's always the case. All right, in case when k is strictly more than 0, we'll have x equals plus or minus square root of k. So basically, 2 solutions. All right, in a case when k is negative, let's say the last version, if k is negative, no solutions at all. All right, so it's good, it's right time to practice. And as you remember, we start from just non-simplified, the simplest form. I mean, it's a simplest form, but it's not arranged properly. So x squared plus c equals 0, it might be equal to another number. So let's consider several examples and let's try to apply this methodology and this strategy. Okay, so for simplicity, let's take the following. We have 2x squared minus 1. Let's say it's equal to 20, let's say 23. Okay, that's in the form x squared plus some c equals non-zero, but another value d. Okay, so what we need to do. So normally we need, the first step here is just to leave 2x squared in one side, as with the case of linear equations. So we'll get 2x squared equals 23 plus 1. So in other words, 2x squared is 24. Then we simplify further and we'll get x squared equals 12. Now we arrive to the form x squared equals k, which is this one, and we're trying to estimate what k is. So in our case, k is strictly more, right, than 0 because it's 12. So we can say that the form x squared equals k will give us k more than 0. So how many solutions? 2 solutions here. All right, and then we just simply take plus or minus the square root of 12. So keep in mind that quadratic equations should have maximum at most 2 solutions. It might have, of course, 1 solution. It might have no solution at all, but the maximum value is 2. So if it's proper equation with k is more than 0, so we'll definitely get 2 solutions. Okay, so however you can simplify the third. Square root of 12 is simply square root of 3 times 4, or it's going to be plus or minus 2 square root of 3. All right, that's the solution. If you want, you can just check it back to original equation here, only to original, because on the way you might make some mistakes. So that's why only check with the original equations, right? So the original equations, only plug there. All right, so let's consider a bit more complicated. I'm sure that is a bit more, but let's see, you guys, the estimate. 2 minus 3x squared, let's say, equals 6. All right, so from here, we want to leave negative 3x here, negative 3x squared. But you can, transfer to the right side and 6 transfer to the left. Okay, we'll have 2 minus 6 equals to 3x squared. Or we just swap that. 3x squared equals 2 minus 6 is negative 4. From where, even if you divide every single part by 3, as we did with linear equations, don't forget these methods, so we'll get negative 4 over 3. So now this is k, right? This is k value. In our case, k is negative. So once it's negative, you need to stop yourself and just think analytically. K is negative, so according to the rules, no solutions at all. So you just cease yourself in solving and just try to see no solutions. Okay, so basically you can put this sign that means no solutions at all. Okay, so let's consider when you have the whole expression instead of x. For example, let's consider another case when you have x plus 1 squared equals to, let's say, 13. Okay, let's say it's 13. All right, how to solve this sort of equation? So I recommend for the first step, like if you feel like not so confident in quadratic topic equations, you just start recently doing something related to quadratic equations. I recommend to input new variable. Let's say this new variable t, okay? So everything that's in the square in the brackets, it's x plus 1, it's all t. So what sort of equation we might have? Now we have t squared equals 13. So as you can see, there is no difference between t squared equals 13, right? And what we've checked before, like x squared equals k. There is no difference whether you use x or you'll be using t. So in this case, you just said, okay, t is x plus 1, and now you have this, right? It's very the same as x squared equals some k, some number, but instead of x, we'll be using t. No problem. T is also a variable. Okay, how to work it out? So k is 13, so 13 is more than 0, so k is more than 0, so we'll have two solutions. Okay, so how to work it out? T is simply plus or minus square root of 13. But because your final answer should contain x equals 2, not t, so just come back and say, okay, instead of t, we have x plus 1. So you just plug that x plus 1 here instead of t, and you set up another equation, which is simply linear one, right? Okay, so x plus 1 equals plus minus square root of 13. So what does mean plus or minus? So it's equivalent to two equations. X plus 1 equals square root of 13, where you can find x, and also x plus 1 equals negative square root of 13, from where you'll have two solutions. So two solutions here. You just transfer one here as well as here. You will get x1 equals minus 1 plus square root of 13 and x2 equals negative 1 negative square root of 13. Okay, so I hope you understand the key approach. So we've considered just, let's do a little recap. So we considered only the simplest form of quadratic equation because it's basics. I also just show you what does mean P2 and what P3 in full analogy, how like each term with a great power than the previous terms arrange new sort of equation like quadratic from linear and cubic from quadratic. So I also actually provide you several steps how to approach to equation in the form x squared equals k. That we actually start doing that, and we explore the ways how to solve this equation. So just pay attention to k, don't forget the k is just a number, and you always need to keep track of k, so that's your starting point. Never start like solving without analyzing k value. Okay, so and finally I'll provide several equations in the simplest form, then a bit modified, and then also completely modified when you have the whole expression squared. So that means you'll have t as a new variable, and cope with t is the same as you just solve with x, but instead of x you will use new variable t. But later on you just come back to to x instead of t, and you solve normally. Okay, this is the way that was the basics. So this is the very starting point, and definitely you need to start from that. Okay, because later on it will be harder to understand. So I hope you enjoyed this video. Don't forget to subscribe, don't forget to share this video to anyone. Just try to help your mates to succeed in GCSE. Just share the link about my channel, and I'll try to do my best so guys you get the highest score. Okay, so we'll be practicing next, and in the next video we'll consider the null factor law or the null factor theorem related to this simplest form, and this also the basics. However, you'll need that in order to get to the more complicated equations. All right, thank you and see you later.